All right, we're picking this up. My video stopped, but here I found the K. And look at there, it's a standard metal. So there's the answer to that question. So I've got a song coming on. It's something like, we got a problem solved. Yeah, all right, we did it. All right, so write down the formulas for compounds named copper 1 chloride and copper 2 chloride. All right, so we got copper is Cu. I looked it up in the back. And we already know chloride looks like this. And when there's just one covalent bond like that, we don't write it on here. We just assume it's a 1, okay? And when we have it as has a double covalent bond, we do like this: copper, chloride, like that. All right. So number 7. In the following equation, what are the reactants? Well, we know that the reactants are always on this side of the equation, right? So we need to just look for those exactly like that. And looks like it's just this one here. So A, that's the answer. 8. Why do chemists use the mole as a counting unit? Well, I think we talked about this because chemical reactions often involve a large number of small particles, so they need a practical counting unit. It's not practical to count in such microscopic terms, so got to cluster things together. Number 9, hydrocarbon butane, C4H10, is frequently used in lighters. When butane undergoes combustion, what products are formed? So this is a trick question, not trick, but there's the hint there. All hydrocarbons produce carbon dioxide, which is CO2, and water when they combust. So if you have hydrogen and carbon of any form on the reactant side, and then you have these on the other side, you know you're looking at a formula of combustion. Combustion. My favorite reaction. So cool. All right. So we'd look for that hydrogen and carbon and how it makes carbon dioxide and water. Boom. All right. Number 10. Identify the following reactions as synthesis, decomposition, single replacement, double replacement, or combustion. Ooh, this sounds like it might be on a test because we already did this for something else. I think in a study guide. Okay, so we've got we have to look for things synthesizing, decomposing, and coming apart, or if things are swapping around. And if they're swapping around, how many do they have in each of the compounds? This one looks like a clear swapperoo. So we've got some N's over here. Let's see here. What do we got? PB is over here. And the PB is over here, but then the NO is over here now, and it was over here. So the NO swapped with the chloride, whatever NO means. Probably nitrogen and oxygen. These swapped. So that is because there's 2, 1, 2, and hydrogen and chloride here. 1, 2, 1, 2, and 1. Wow. 2, 3 maybe? I'm not sure here. These are a double replacement. Okay, so this is a double replacement. All right, boo. So this one, as much as I want to just look for those things I told you, I also forgot, we need to keep in mind there is the possibility of carbon and hydrogen turning into We have oxygen and water here. Was it? No, CO2, sorry. Carbon dioxide and water. And when we have a hydrocarbon on one side, on the reactant side, carbon dioxide and water on the other side, what do we have? Oh, my pen broke. Combustion. Woo! All right, combustion. All right, next one. All right, we got a 1 and a 2, calcium hydrochloride. We got the 2 and the 1, looks like a swapperoo. I'm going to call this a single replacement. Excuse me. This one takes 2 things, merges them together. We're going to call that synthesis. This thing takes 1 big compound, turns it into 2 separate elements, so we're going to call that decomposition. Okay? There's the answer to that. 11. You guys are going to do so great on the test. All right. Is the combustion of propane endothermic or exothermic? All right. So when you have combustion, I don't know of any time it doesn't create some sort of energy of some sort. But this is definitely when you use propane in your gas grill. And you feel the heat and you can cook some steaks on it. That is exothermic. There's the fire on the grill. This is my grill. And there's some hamburgers getting totally burned. Charcoal. Whoa. All right. When propane reacts with oxygen, does the surrounding area become warmer or cooler? Well, I think when propane and oxygen react, it's exothermic. So, and heat is released. So, yeah, it gets warmer. I think that is an example right there. Okay. Why doesn't methane react with oxygen at room temperature? It says at room temperature, the collisions between methane molecules and oxygen molecules are not energetic enough to start a reaction. It takes the energy of a spark to do that. So it says it needs a spark, which is probably related to it. What did we call it? That energy that it requires, activation energy. That's probably what that is. All right. In what type of reaction does one reactant form 2 or more products? One reactant form 2 or more products. Well, that sounds like decomposition is my guess. Yes. All right. 14 is D. I double checked it. All right. 15. Which of the following is a double replacement reaction? Let's look at them. Do we have? I see that hydrogen and carbon over here is again hydrogen and chloride, and we have nope. Hold on. Nope, that's not it. We're on 15. This is it. That's a double replacement. I thought that was combustion. It's not. This is not CO2. So this is it. It's A. All right, 16. I love it when we can just move right on. Which equation describes a synthesis reaction? So we need to take two things over here, and then go into one thing. And there's only one of those that's even possible. 17. Which of the equations in question 16 describes a single replacement reaction? Single replacement. So they're going to not have double compounds in it. And I'm going to say it would only have one double compound and a single on the other side. That's right. So C is our answer to that one. So you can see that they both do that. All right, how are reactions related to chemical bonds? Bonds in the reactants of a reaction are broken and bonds in the product are formed. So that's how they're related. I'm going to say that again because that's really kind of confusing. All right, so bonds in the reactants of a reaction. So let's look at an example. Bonds, the reactants are over here. Let's do one I didn't just mess up. Here we go. Bonds in the reactants are broken and bonds in the products are formed. So that is the answer to how reactions relate to chemical bonds. Reactions relate to chemical bonds. There you go. Okay. And I believe where we get a lot of energy for all these things too. All right. With all that, that was a tough module, but you did it. You got through it. It was many, many videos long, but we got through it. And look at poor Maisie Heaven. She's like, oh, let me hide. This is just a nightmare. No, I'm just kidding. This has been a lot, but we did it, and I'm looking forward to physics in the next module. It'll be fun. So take care, and best wishes on your test. Bye-bye.